Hello. I thought I would give you some instruction on this week's lab, which is Hubble's Law 2. So that when you go to Canvas and then you go to Modules and then you go to Labs, you're going to open up Introduction to Astronomy Labs, Unit 4, Cosmology. And then down at the bottom, you're going to click on the tab that says Hubble's Law 2. Do not click on 17 Hubble's Law because that one uses a computer simulation that you don't have access to. So if you open up Hubble's Law 2, that one it's essentially the same lab, but I've adapted it so that you'll be able to do it. Remember to do the pre-lab questions for it. And if you would open that up for me right now, and then go on down to the concept introduction. So by this time you should have watched my videos on measuring the universe, which was, I think that's lesson 20. So I encourage you to watch those videos, especially the part where it talks about Hubble's law. So I encourage you to watch that first and then come back and try to do the lab that goes with this. But here under concept introduction in the lab, it talks about how you have the cosmological redshift is the kind of like the Doppler effect, in that as a galaxy is moving away from us, then its wavelength is going to be shifted. And so the speed of that galaxy can be determined using that equation 17.1, where you take the change in the wavelength, where you take the two wavelengths and you subtract them, and then you divide it by the original wavelength, and then you multiply it by the speed of light, but you have to use 300,000 kilometers per second for your C value for that. Well, Edwin Hubble made a plot of the speeds of galaxies versus their distance away from the Earth, and he found that it made a straight line. And then he found the slope of that straight line, and that turns out to be Hubble's constant, which the currently accepted value for Hubble's constant is 22 kilometers per second per mega light year, or it could also be written in terms of megaparsecs, in which case it would be 72 kilometers per second per megaparsec. Now your goal is to make a graph that looks like figure 17.2. So that's going to be the point of the lab, is to make a graph that looks like that, then to find the slope of that graph, and then that should turn out to be Hubble's constant. Okay, so if you scroll on down to the procedure, I have found the wavelengths for different galaxies, and I put them in the chart for you. So you've got Galaxy A, which it's located 0 megaparsecs away from the Earth. And then its wavelength then would be the rest wavelength, and so that would be 68.47. Okay, then you're going to take the Doppler shift. So you're going to take that number there, 3968.47, and you're going to subtract it from 3968.47. So I'll tell you that first one should be 0. In that for Galaxy A, the Doppler shift should be 0. And then you're going to calculate the redshift. So you're going to take whatever you've got there in column E, and you're going to divide it by 3968.47. And so again, that turns out to be 0. So for galaxy A, the Doppler shift is 0 and the redshift is 0. And then you're going to take column F, so whatever's in column F, and you're going to multiply that by 300,000, and then you put that in column G. So for galaxy A, take a guess what the answer is going to be. Well, it's going to turn out to be 0 again. So A is a big fat 0 for all three of the columns. Now when you go to galaxy B, however, things are going to start to change. So you're going to fill in all three of those columns. Now there is a way to have Microsoft Excel do that for you. You could look that up online if you want to find out how to do it. But you could just use a regular calculator in order to do it. And if you don't have a calculator, remember that your computer has a built-in calculator. Okay, then once you have done that, go on down to where it says Part 4. It says summarize your data in the following chart. So that you're going to have the galaxy ID, which is going to be A, B, C, and so forth. You're going to, for each of the galaxies, it has a certain distance. So put that in the second column. And then the third column is the very last column on the previous chart. So the speed at which each of these galaxies is moving away from the Earth. Okay, you're going to graph it. So hopefully you remember how to graph using Microsoft Excel. So if you don't, I have put on Canvas another document that shows you how to do that. So there's a document that shows which buttons to click on your computer in order to be able to graph. And I'm going to put that under the, let's see, I think I'll put that under classroom materials. So if you go to Canvas and then modules and then under the classroom materials, I think that's where I'm going to put that document, and it'll say something like how to graph using Microsoft Excel. So I'll put that on there just in case you've forgotten how to do that. So you're going to make a graph. I do want you to label the up and down part, and I do want you to label the sideways part, and I do want you to put a title on it. Then you're going to add a trend line, and then you're going to display equation on the chart, and then you're going to, based on that equation, you're going to figure out what the slope of that graph was, and hopefully it should be Hubble's constant. So you'll put down the slope of your graph in the chart, which is immediately underneath the chart that you've been filling in, and then you'll also put in the actual number for Hubble's constant. Then go down to part 5 of the lab, determining the age of the universe. And this is mentioned in the lecture, so lecture 20, about how to do all of this. And it turns out that the age of the universe, so go down to where it says equation 17.7, the age of the universe T is going to be equal to 300.3 divided by Hubble's constant. And then that answer should be in billions of years. So you're going to take your Hubble constant, which was the slope of your graph, and take 300.3 divided by that number, and then hopefully that should turn out to be the age of our universe. And then you can look up on the internet what the actual age of the universe is in billions of years. And then finally, don't forget to do the post-lab questions, especially questions number 6 and 7, because that is pretty much what you're going to be given on the final. So if you can do those 2 questions, then you can pretty much do the question on the final that deals with Hubble's law. So you've got a week to do this, and so I would this will be due sometime next week, which will be around 4/19. So you got plenty of time to do this, and if you do have any questions, give me a call via email. Okay, so good luck, and get started on that lab.